When you turn on an oven, the air inside is heated by conduction, which is the spontaneous transfer of heat from a region of high temperature to a region of a lower temperature. This newly hot air is circulated by convection due to the different densities between hot air and cold air. This eventually brings the whole oven up to the preset temperature. Normally, this heat is contained within the oven by a heat-proof material that is designed to reflect the infrared waves created by the hot air.
Brownies are a lot like cookies when it comes to the baking process, except cookies bake individually and brownies bake as one big block of brownie. Just like cookies, convection occurs when the warm air circulates around the oven, and the brownies are baked through heat transfer. When we first put the brownies into the oven, it's a pasty liquid, and by the time it's cooked, it's a moist solid due to the process of vaporization of the liquid compounds in the brownies.
We put all the materials we needed for the popsicles in the blender, and as we started the blender, we created inertia. As the blades spun around, they also created friction between the bottom of the blade and the bottom of the blender. After we poured the liquid into the molds, we placed them in the freezer that was 32 degrees. The first part of the freezing process is the liquid's top freezes first. Then, as the liquid continues to freeze into a solid, the frozen parts float to the top because the solid ice becomes more buoyant. The expansion upon freezing comes from the fact that the liquid crystallizes into an open hexagonal form. We all know that internal energy will not spontaneously flow from a cold region to a hot region. It can be forced to do so in a working system. Refrigerators and heat pumps are examples of engines that cause energy to be transferred from a cold area to a hot area. Usually this is done with the aid of phase change. A refrigerant liquid is forced to evaporate and extract energy from the cold area. Then it is compressed and forced to condense in the hot area, dumping its heat of vaporization into the hot area. Microwaves are meant to absorb some chemicals from food, but mostly water, by changing it from a liquid to a vapor. Because the electric field is constantly moving, hence the water molecules are constantly moving. The frequency of the microwaves is optimal because the time it takes for the electric field to oscillate is constant with the time it takes for a water molecule to rotate 180 degrees. So the water molecules are rotating as fast as possible. As they rotate, they bump into other molecules surrounding them, transferring some kinetic energy into other molecules. By the kinetic particle theory, if the particles in the food have more kinetic energy, then the food is going to be hotter. When the wire within the toaster has the right amount of electricity running through it, the wire is able to get hot, but not hot enough to melt, and it won't rust, break, or get tarnished easily. This material is used in most electrical heating systems today, including water heaters. When you flick the switch to put the toast down, it gives off an infrared heat energy and some visible light, which is why you see the red light coming from the wires within the toaster. There is a spring-loaded system in a toaster as well. When you push the lever down, this pulls the springs and pushes the tray down until it reaches a latch and holds it into place. The latch that the tray holds into place is linked to a timer, which is controlled by a switch. When you start the toaster, electricity runs through this switch and the metals heat up, expanding and eventually pushing apart, breaking the circuit. This releases the spring-loaded tray and your toast pops up. As you heat up that pot of water, more of the molecules want to move into their gas phase. The amount of water that evaporates as you warm the water is described in a very simple and beautiful relationship. The relationship 1 is the pressure that you measure if you had only water vapor and no extraneous air molecules. The second one is a fraction only of the temperature. If you increase temperatures by a small increment, then the partial pressure of the water increases